This video is part of an online course of Calculus 1, and I'm gonna solve some examples of compositions of functions. Let me start by example 1. Assume that this table is given. So x can be -1, 2, 4, and 8. The function f at -1 is 0, at 2 is 6, at 4 is 8, and f of 8 is 2, and g at -1 is 4, g at 2 is 5, g at 4 is 0, and g at 8 is -1. Okay, find FOG for any x and GOF for any x. Okay, so let me start by FOG of the point -1. It would be, based on definition of compositions of function, it would be f of g of -1. What is g of -1? G at -1 is 4, and now I need to find f of 4. F of 4 is equal to 8. Good. What is FOG at 2? It would be f of g of 2. I'm writing definition. What is g at 2? G of 2 is equal to 5. So f of 5 is undefined. And that's why I can say that 2 is not in the domain of FOG because it's undefined. Okay. How about FOG of 4? It would be f of g of 4, and it would be g of 4 is equal to 0. You see, g at 4 is equal to 0. Now, what is f of 0? Is equal to actually undefined, because f of 0 is undefined. That's why I can say that 2 and 4 are not in the domain of FOG. Okay, let's move on to the next one. FOG at 8. It would be f of g of 8, g of 8. G at the point 8 is equal to -1. Now I need to find f of -1. F at -1 is equal to 0. Very good. We found FOG for all -1, 2, 4, and 8. Okay, let's calculate GOF. I'm gonna move this one down, and I'm gonna calculate GOF. GOF at -1, it would be g of f of -1. You get the idea. F of -1 is equal to 0. I need to find g of 0, which is undefined, as you see. How about GOF of another point, which would be g of f of 2? Okay, f of 2 is equal to what? It's 6. So g of 6, where is that? It's actually undefined. How about GOF of 4? So I can say g of f of 4. F of 4 is equal to 8. So g of 8 is equal to -1. GOF at 8, it would be g of f of 8. What is f of 8? F at 8 is equal to 2. So I need to find g of 2. G at 2 is equal to 5. Perfect. I can say -1 and 2, it's not in the domain. They are not in the domain of GOF. Okay. And for example, you see GOF at -1 is undefined, but FOG at -1 is equal to 8. So GOF and FOG, they are not necessarily equal to each other. Okay, so f of g is not necessarily equal to g of f for any values of x. Okay, very good. Let's go to the next example. Example 2. Let f of x to be absolute value of x and g of x to be square root of x and h of x to be x squared minus 9. Find f o g o h. Okay, let's do it. F o g o h at any x is equal to what? It's equal to f of g of h of x. There you go. Let's see, what is h of x? H of x is x squared minus 9. Okay, so I need to find f of g of x squared minus 9. Okay, you see here, g of x is square root of x. Instead of x, I have x squared minus 9. So for any x that I see here, I need to put x squared minus 9. So it would be square root of x squared minus 9. Okay. Now I have f of x squared minus 9. Okay. So f of x is absolute value of x. Now instead of x, I have this square root. Okay, so I have what? Let me move this one a little bit. So it would be absolute value of square root of x squared minus 9. Since square root is always positive, absolute value of something positive is that thing. So it would be just square root of x squared minus 9. That is f o g of h. Okay, let's go another example. Express cosine cube of x minus 4 as a composition of three functions. Three functions. Okay, let me actually leave this one in here. So let me think about this. Cosine would be one function, and then x cubed could be another function, and x minus 4 could be another function. So I'm gonna say h of x to be x minus 4, and then g of x could be cosine x, and then the last one would be cube. Now let me check my work. F O G O H of x. Okay, it's what? It would be f of g of h of x. Okay, h of x is x minus 4. Then I have g of x minus 4. G of x minus 4 would be cosine of x minus 4. And then h of cosine of x minus 4. So f is a function that makes everything cube. Okay, so this one would be cosine. Actually, let me write it in here. Oops. So this one would be cosine cube of x minus 4. Or I can write it this way so that you understand it better. Very good. The same function.